Let's find a value of an oblique triangle using the law of sines. In an oblique triangle ABC, where A is 34 degrees and B is 68 degrees, also know that A is equal to 4.8, and that's the length of one of the sides. We want to find side B to the nearest tenth. Now note, since we do not have a right triangle, we cannot use Pythagorean or regular trig functions. We have to use the law of sines. So what values do we know? We know side A, which is 4.8, and angle A, which is 34 degrees. And that's a good ratio to use in our law of sines. 4.8 divided by then the sine of 34 degrees. That is then equal to B divided by the sine. Now we have to recognize the angle here. Since side B is opposite angle B, we're going to use the sine of 68 degrees. Now we have a nice proportion. We're going to cross multiply. We have B times the sine of 34 degrees. That is then equal to 4.8 times the sine of 68 degrees. To solve for B entirely, we'll divide both sides by the sine of 34 degrees. What you do to one side, you have to do to the other. So in this case, we've solved for B. That's the exact answer for B, which is approximately 7.959 units. And remember, this is the length of that triangle there. Now, we need to round this to the nearest tenth, and so this rounds up to approximately 8.0, and so that is our B value, approximately 8.0.